Alright, so this is a tutorial on how to solve the 3x3x4. The first thing to know is the notation for the algorithms, because as you can see, the right, front, left, and back faces, they can only do 180-degree turns. They can't do regular 90-degree turns. So when I'm referring to an R, it's just a 180-degree rotation, because this would make no sense because you can't turn anything else. So an R is this, and an F is this. There's no R prime or F prime because they're essentially the same move. And for this tutorial, I'm not going to be using the left or back faces at all. So those are unimportant for this tutorial. For the up and down faces, it's pretty much the same as before. So this is an up, this is a U-turn, this is a U prime turn, clockwise and counterclockwise. This is a D turn, and this is a D prime turn. To move these two layers, it is a 2U turn, and that's clockwise, 90-degree clockwise turn for these two layers, and then a 2U prime would be like that, counterclockwise. Same for the down, so 2D and 2D prime. To move it 180 degrees, it'd be 2U2. So the same for down, 2D2. Alright, so the first thing to do is to scramble a cube. To scramble it, what I like to do is just to do right and left faces rotations. Sometimes I throw in a front, just depends. And what I like to do is rotate sometimes 2 layers, sometimes only 1 layer in between those turns. Sometimes I only rotate 1 layer in the middle, like that. It just depends. Alright, so now that you have your scramble, the first thing to do is to solve this third layer right here. What I like to do is I like to keep the white on top and the yellow on bottom because it helps me remember my color scheme. Since these centers can move, and so there are no centers that stay in place, so you don't know which colors are actually which. So what I like to remember is red, white, and blue. So the way to start it is you want to get, for me at least, the red in this third layer. Right here I already have one in place, but for the rest of them I can just, what you want to do is you want to get it in the third layer center, and then you will just rotate it to where you want it to go. Like for this one, I want it to go right here, so I put it directly on top and I just do a 180-degree turn and it goes into place. So now I have my first two, and since orange is opposite of red, I'm going to put orange down here, and I already have an orange piece up here, which is good for me. So I just do a 180 rotation and it puts it right in. And here I already have a green piece, so that saves a lot of, well, that saves me from putting that green in. So the next step is our first algorithm. It's to solve the edges, and what we want to do is you want to find the piece that has the opposite color of what this color is supposed to be. So this is red and blue, right? So this piece should be red and blue. But when you want it up here, when you're solving for it, you want it to be opposite. So this side, these two should not match. This one should be over here. So instead of red and blue here, you want red here and blue here. So we see a red and blue piece here, so we'll rotate it over and see if it works. And since these two colors don't match and these two colors don't match, this piece can work. So it's red and blue, but when you put it in, it's supposed to be red and blue. So the color has been swapped. That's the way we want it to be. We want it in the front right corner right here. So the algorithm is R, 2U, R, 2U prime, R. Alright, so see, we have that put in now, and it's in the right direction. If we had done it so that this was red and this was blue, it would have ended up switched right here. So the next piece we'll move on to here. This is actually a good example. I can show you what happens if I put it in when the colors are matching. So if I perform the same algorithm, R, 2U, R, 2U prime, R, you can see that this has been swapped. Alright, so if we look for the piece that actually should fit in here, this is red and green, red and green, and red and green. So this is opposite colors. We try to do the actual algorithm and see that color flips in and it works. So for our last edge piece right here, we see orange and orange, blue and blue, and they're on the flip side. So R, 2U, R, 2U prime, R. Alright, so now we have the third layer done. The next step is to solve the second layer. In the second layer, you have one of three cases that you can have. The first case is that you will have no headlights. Second is you have one set of headlights. And third is you have all sets of headlights. Headlights in this, for this tutorial, means that you have two pieces that are of the same color facing the same direction. The centerpiece isn't important right now, but you want to have these two edge pieces the same color. Since this is red and orange, they're clearly not the same color, so these don't count as headlights. Right now I'm in the situation where I have no set of headlights. If you have one set of headlights or two set of headlights, or sorry, all set of headlights, it's simpler than this one because you can just move on from there. But this is also helpful because it's basically the same step. So there's an algorithm. If you have no set of headlights, it doesn't matter how you orient the cube right now. If you have no set of headlights, you want to do this algorithm. R, 2U, R, 2U prime, R, 2U, 2D, R, U prime, 2U prime, R, 2U, R, and then you will have one set of headlights. Right here, we see our first set of headlights. And so here's a situation if you only have one set of headlights. You want the headlights to be on the left face. And you perform the algorithm I just showed you one more time. So R, 2U, R, 2U prime, R, 2U prime, 2D, R, 2U prime, R, 2U, R. And now all the headlights have been put in. And so you can see these are headlights because these two are the same color. And it's not important whether or not the centerpiece is the same color or not. So after this, you will have one of many situations. One is that all of the centers are completely solved, which I've never gotten from solving a 3x3x4, but I'm pretty sure it's uncommon. One is that you will have three centers not in place, which like I do here, you will have none of the centers in place, but the center that's supposed to be in there is adjacent, or you will have all of them facing the opposite direction. So one of the situations you will have after you have set up headlights is a situation where you only have two that are misplaced. This is probably the easiest one other than having it completely solved, which is you only have two and the two need to swap adjacently. So this this algorithm actually does just that. It swaps the one in your right face with the front face. So it's R, 2U, R, 2U, R, 2U2, R, 2U2, R, 2U, R, 2U prime, R. And that swaps these two. If you're in another situation where it's on the opposite faces, you have to swap it multiple times for it to work. Alright, so one of the other cases that you might run into is just that there's really no pattern to how the centers are scrambled. What you want to do in this case is just pick any two edges where one will be solved, and just solve that end first. So this one would be R, 2U, R, 2U, R, 2U2, R, 2U2, R, 2U, R, 2U prime, R. And so now we're back, we have the situation with 3. So now what we do from here is you want to solve it so that afterwards you'll there's two adjacent to each other. For example, if I were to solve these two edges right now, that would solve the blue side, but the red and the orange side would be still not fixed. So when that happens, you would have to mess up this blue one anyways to solve those two. So you want to solve the one that will leave only two adjacent pieces unsolved. For this red and blue side, it would solve the red side so that the orange and the blue side are the only two that are left unsolved. So that is a situation that we want. So we perform this algorithm once here. R, 2U, R, 2U, R, 2U2, R, 2U2, R, 2U, R, 2U prime, R. And so now we can just perform the algorithm one more time on here, and we'll have all of the centers solved. Alright, so the last situation is that you have all the centers not in the right place, and they're on the opposite side of where they should be, like the red and the orange. The red and the orange are on the opposite sides. So in this situation, all you can do is pick any two random sides, perform the algorithm once, and then go from the last situation from there. So from here, I'll just do the blue side to get that out of the way. And then I'll probably do the orange side, so I'm left with green and red adjacent to each other. And then the last one, I just have these two sides to fix, so that they're back in place. And from here, we are going to solve the bottom yellow cross. So what I like to do is I like to line it up with any yellows that are here, if any. If there are none, then you just start off with whatever you have. So what you want to do is line it directly on top of where the edge is supposed to go, just like what we did for the centers. So this orange piece is supposed to go here. And same as the center pieces, we just do a 180 rotation. And what's important now is that you want to always stay turning this right face. So I can move the top and the bottom faces however I want, but I want to make sure this one is the one I'm always turning, because then you see it messes this up. So now I'm going to put in the green piece here and finish off with the red. And I still want to stay with this side now that I'm going to be putting in the corners. See, we have our yellow cross, and now we're going to work on the corners. So same thing, I still want to just work on with this right face. So green and red, I'm going to go to the green and red side, and it's supposed to be the opposite, so that's what it is. I'm going to perform the algorithm. This is the same algorithm as the edge pieces, except this time you're just turning with the up and the down layers. So this algorithm is R, U, R, U prime, R. And so we have no more yellow corners, but here we see these yellow corners aren't in place. So we perform the algorithm on any one white corner, it doesn't matter. Perform the algorithm one more time, R, U prime, R. And so we put the orange and green piece in. We'll do it one more time with this one. And now we have the bottom three layers solved. At this point, sometimes these two pieces may be swapped, and that's parity, but remember, you always just want to work on the same right face. So now we're going to go with the assumption that I'm still working with this right face. Now we're going to find our headlights in the top layer. This is the same situation with the second layer headlights. So if you know the previous situations from before, you know how to handle these. So I have one set of headlights here, so I will just be doing the algorithm one more time, remembering that this is always going to be my right face. So R, U prime, R, U prime, D, R, U prime, R, U, R, and then D prime to fix the bottom layer. And now we can adjust the top layer to wherever we want it to be, to match the colors that are here. And in my situation, I have two edge pieces that are across from each other. So now I have to break up this one to make sure these three can be all put back to where they're supposed to be. So this is R, U, R, U, R, 2U, R, 2U, R, U, R, U prime, R. And remembering that I said not to rotate the cube, you want to always just rotate the top face so that this is still your right face. We're gonna fix this one, so this is green, and this will just be orange and blue. So R, U, R, U, R, 2U, R, 2U, R, U, R, U prime, R. So now we have that one solved. We're gonna rotate the top layer so we have it in the front and the right face. And we'll perform the algorithm one more time. R, U, R, U, R, 2U, R, 2U, R, U, R, U prime, R. So now we have the top layer fixed. Your cuboid may or may not have this completely solved. If it is solved, congratulations, you've just solved a 3x3x4. If not, then you're in the same situation as I am, where I have parity. All of the algorithms that we've been using, except for the headlight algorithm, they all cause parity. But the reason it didn't matter when we were working on this one is because there's no layer in between here that it would affect. But now that we're working on the top layer, it affects these two middle layers. But this, to get rid of the parity, is actually really simple. It's just this algorithm. 2U2, R, F, 2U2, U2, F, R, 2U2. So that's how you get rid of parity. That algorithm, including all of the other ones in this video, can be used to solve any other 3x3x puzzles. They just need to be applied differently. So instead of 2U, maybe it would be a 3U or just a 1U. Same for the parity algorithm. The reason that in the middle of the algorithm you do 2U2 and then a U2 is so that only this layer is affected. In bigger cubes, you would just adapt to whatever size of or whichever layers need to be, the parity needs to be fixed on. So that is the tutorial on the 3x3x4. If you need more sample solves, in case this solve was a different situation as yours, I will have other example solves on my channel, and they will be, you can use those to reference any other situations, or if you need extra help solving the 3x3x4. If you have any questions, you can comment in the comment section below, or suggest any other tutorials that you would like to see.